Welcome to Section 3, where we'll talk about developing web applications with Spring Boot. Specifically in this section, we're going to take a look at Spring MVC auto configurations, REST documentation with Spring REST docs and Swagger, templating with Timeleaf, reactive web programming, configuring embedded servlet containers, and serialization with Protobuf, Avro, and Thrift. Spring MVC is one of the most popular Spring modules as well as one of the most popular frameworks for building web applications. In this video, we'll show what benefits Spring Boot provides when developing a web application with Spring MVC. We'll cover static resources in WebJars, serialization with JSON, error pages, and unit tests with WebMvcTest. Spring Boot provides Spring MVC with a lot of auto-configured functionality right out of the gate, such as serving static content and converting objects to JSON. Let's talk about what support is given to static content. The following directories are configured by Spring Boot to provide static content: static, public, resources, and meta-inf resources. You can add or change these directories with the spring.resources.static locations property. For instance, if you want to serve all of your HTML files out of the HTML directory, you may add it by setting the static locations property to class path HTML. Note that this will override the default directories, so if you want to use those, you'll need to add them back to this property. Spring Boot also allows you to serve static content out of jar files known as WebJars. Spring Boot will map requests for /WebJars to the WebJars resource location. Otherwise, you'd have to configure this mapping yourself. Let's take a look at this in action. When we access our current index page, we'll notice that Bootstrap styling is set in the tags, but they aren't being applied when we view the page. We'll add the Bootstrap WebJars and Maven dependency, as well as the WebJars locator, which will allow us to use resources without having to specify the version. When we access the index page of our application, we can now see the styles are applied. Spring Boot will configure Spring MVC to automatically convert HTTP requests and responses to JSON, and the JSON can further be customized by creating your own serializers and deserializers. In our simple controller, we have an order endpoint that will return an order object which will be converted to JSON. However, it doesn't serialize to the format we want. Since the need to serialize data is a common occurrence with building RESTful APIs, Spring provides some convenience for this functionality. The JSON component annotation will automatically register your serializers and deserializers with Jackson when the application context is loaded. Another convenience is the JSON object serializer and JSON object deserializer classes that you may extend to reduce some of the boilerplate code that is needed. Take a look at our simple serializers class that implements these tools. We've created a simple serializer for the order object, and when we start our server and navigate to the order endpoint, we now see the format we expect. Unfortunately, errors happen, so Spring Boot sets up a default error mapping and global error page. Let's see an example when we access the myError endpoint, which throws a general exception. You'll notice this message returns a 500 status code. It's possible to create a custom error page for that specific error code by naming it 500 in a directory named error in your static path. Here we have created a 500 page that simply states an error has occurred. Now when we go to the myError endpoint, this is the message we'll see. If you don't want users to see your fancy error pages, then you need to write tests for your Spring MVC endpoints. This is made much easier with the use of Spring Boot's WebMvcTest annotation. Let's create a unit test for a simple controller called Simple Controller Test with the WebMvcTest annotation. Because we added the WebMvcTest annotation, we'll have a mock MVC bean auto-configured for us to use in our test. This will allow us to test our controller endpoints without having to spin up our application server. To further add to our tests, if we have a Selenium or HTML unit as a dependency, Spring Boot will also give us a web client. This will allow us to test the actual contents of our HTML. For example, this test index method will check the contents of our index page and assert the contents are what we expect.